our glass mineral wool manufacturing process at Knauf in St Helens. We begin our tour at the batch plant. This is where the raw materials used in the process are delivered and stored. The main virgin minerals that we use are sand, soda ash, borax and dolomite. However, up to 80% of the materials that are fed into the furnace is actually recycled glass, also known as cullet. There are two types of recycled glass: plate glass, which comes from windows and car windscreens, and container glass, which comes from bottles and jars. The raw materials are delivered by a vehicle, offloading it pneumatically into storage silos. We have 4 to 5 days worth of raw material storage capacity in the silos. When the furnace is ready, it'll call for a batch. The batch plant will automatically weigh out the correct quantity of each ingredient and will mix them together into a batch. The batch of materials travels along a conveyor belt and the bucket elevator takes it up to the floor above. This is so that we can feed the batch into the 2-day silos that you can see either side of the furnace. We have about 8 hours worth of batch materials ready to feed into the furnace. So if we have a problem with the batch plant, then we have 8 hours to fix it before we have to take corrective action on the furnace itself. From the 2 silos, the batch materials are fed via the water-cooled screw feeders into the furnace tank. The furnace is gas-oxygen fired with electric boost, which is an environmentally friendly process. Inside the furnace, you'll see a bath of molten glass with some unmelted batch materials floating on the top. With gas-oxygen burner flames above the bed of molten glass, which are providing 70% of the heat. The temperature is around 1400 degrees Celsius in the furnace. You won't see the electrodes as they are below, submerged in the glass. In St Helens, we have 1 furnace but 3 production lines, so we have a series of electrically heated canals transporting the molten glass to these lines. They are electrically heated to ensure the glass is maintained at the right temperature and therefore at the right viscosity for the fiberizing process. The binder plant is a similar principle to the batch plant in that we take in bulk delivery of the raw materials, but instead of minerals, we take in liquids. The binder plant is a completely automated facility. The purpose of the binder is to effectively glue the fibres together to form rolls or slabs of insulation. On our loose wool line, we do not add binder. However, we do add a silicone emulsion, which is also prepared in the binder plant. The raw materials are pumped from the bulk storage tanks outside. They are weighed out into correct quantities, mixed together, and the binder is pumped over to the fiberizing area where you can see it being applied directly to the fibres. To create the fibre, the molten glass is spun very fast through a hot spinner. The spinner is filled with the molten glass, and centrifugal forces cause the molten glass to escape through thousands of holes in the spinner wall in a radial direction, creating the fibres. Outside of the spinner, we blow hot air, directing the fibres in a downward direction, allowing us to collect the wool in the hood, but also further attenuating the fibres, stretching them out and making them thinner. Outside of that, we have a compressed air blower, determining the wool length, adding a little more attenuation and starting to cool it down before applying the binder. The first spray ring is just water, cooling the fibres down, which needs to be done first before we can apply the binder from the second spray ring. The innovative binder we use is unique to Knauf insulation and is called ECOS technology. It was developed by our research and development team to create a bio-based organic binder which has no formaldehyde, colours or dyes added to the process. The mineral wool is then distributed side to side to ensure even distribution and therefore density across the conveyor. In the control room, there is a high level of monitoring and control. There is CCTV coverage of key process areas, glass temperature monitoring, glass level monitoring, and control screens for the fiberizing process on all 3 production lines. It is here that the quality and output of the fibres are controlled. Pollutants are removed from exhaust gases by means of electrostatic precipitators, with emissions being continuously monitored by emissions monitoring instrumentation. Therefore, if you look at the stacks, there is very little being emitted, and what you see is essentially steam. We work closely with the Environment Agency to ensure the rigorous standards are maintained and complied with.